I'm going to talk about Git and Github, which hopefully all of you will be using this semester because Observatory uses those to work, and otherwise we won't register you as having done anything. A lot of you are new, right? How many people, is this your first semester? Okay, and I'm guessing a lot of those people have not used Git or GitHub to manage a project before. So this is just sort of give you a general overview of what these tools are and the sort of philosophy behind them and how to use them. So, what is Git? Git is a source code management and revision control system, which basically means it's something that you use to manage your software project. Since the early days of programming, people needed a way to collaborate with others on their projects, and there are a lot of tools that sprung up to accomplish that task, and Git is basically just the latest and greatest in ways of accomplishing that. And its big feature that differentiates it from other source code management systems is that it's distributed, meaning there's no like master server, but I'll get more into that later. Git was created by Linus Torvalds, who created another famous program that some of you might have heard about. Yes, Subsurface, the scuba diving tracking logging system. And Linus has a habit of naming his projects after himself. So first Linux and now Git. That's a joke. So Git was created in 2004 to help with the development of Linux. The current source code management system that the Linux team was using didn't really scale too well, and it's starting to take really long just to apply patches, like 25 seconds to apply a patch. And also the creator was getting sort of skittish about having it open source, and he closed it. So the Linux team had to very quickly switch to a better alternative. So development started on April 5th, and by April 8th it was self-hosting, which I think is amazing. That means they were using Git to host Git. And by the end of the month, it was as fast as Linus was hoping for. It's actually applying patches at a rate of 7 patches per second, which is like 200 times faster. Yeah, Avi?
So you mentioned the previous one was having scaling issues and was previously open source. Was that
BitKeeper? Yeah. Yep.
What I thought that the whole controversy about that was that it was never open source to begin.
I'm not too clear on the exact history, but that's what I gleaned from the Wikipedia article. So, GitHub is an online hosting service.
Luke, speak up!
I'm not loud enough.
No, you're not.
Oh, sorry. Okay. GitHub, it's a service that lets you host your Git projects online. It provides free hosting, and it makes Git sort of more accessible. It's a great way for people to collaborate on their projects together online. Okay.
Is he loud enough now?
I didn't realize. I thought I was projecting so well.
Luke, you need to be like streaming on every slide.
Really?
Yeah, your indoor voice is good.
I don't know if I can do that. Maybe you should just go like this. Okay. So why should you use Git? Git is basically much better than any other management system you could think of for managing your project. So one thing you might do at a very, very basic level is each time you get to a new version of your project, you would like make a zip file of the code in that current state. And then if you lose your current version or you want to go back, then you can restore it from that. And Git in a way is a lot like that, but it's a lot easier than making a new zip file for every version, and usually it's so easy that you do it much more frequently than every version. You break things down into things called commits, which I'll talk about later. You also have history, so you can go back and look at all your previous versions, and something called branches, which basically lets you spin off like a different variant on your current project and sort of try out some new approaches, and then if they're successful, you can merge them back into your main branch. And like I said before, it facilitates collaboration because Git makes it very easy to create patches that you can send out to all the other developers working on a project, and then you can all be sure that you're up to date with each other. So why would you use GitHub? Well, the main reason is that it's accessible from everyone, and that it makes it very easy for people to clone your project and work on it. And it serves as sort of a master backup, so even if all of your local copies of your project are destroyed, you know that it's safe on GitHub, so that's nice. It also has support for bug tracking issues and pull requests, which I'll talk about in a bit. And it looks nice. It's got a pretty interface for doing all this stuff, and it makes working with Git a lot more visual, which I think is essential, because Git is famously very, very complex, and most people don't understand it very well. So GitHub helps that. All right, so this is a basic overview of everything you should know how to do with both of these, just at the very basic level. I'm not going to go through exactly how to, like, the commands of doing all these. But
That's the whole point of the presentation.
no, see, that's dumb, because if you give people a bunch of code snippets in a presentation, it's not like they're going to be typing it. But anyway. So I actually wrote a big Git guide, and I posted it to the mailing list. Hopefully some of you saw that. If not, I'm plugging it again at the end of this presentation, so you should all go and look at that if you want to know how to actually do these things that I'm talking about. Okay, so let's get into it. Commits. So a commit is the most important structure in Git. Basically, it's a snapshot of the current state of your project. So each time you make a commit, it's like the project gets updated, and you can rewind back to previous commits and look at how your project was in the past. And they're represented internally as a diff. So that means is it's not copying every single file over each time you make a new commit, but instead it only keeps track of the difference between your current commit and your previous commit. So that looks something like this. So the red lines show that some code was deleted, and the green lines show that some code is added. So best practices for commits. Basically, more is better. You don't want to be stuffing a bunch of different new features into one commit. And when you have more of them, it's just easier to understand, like, the process. It makes them easier to merge if there's merge conflicts. And plus, you get more imaginary internet points on GitHub, because you get like a +1 each time you commit on GitHub. And it looks nice, especially for recruiters looking at your profile page. So why not? And you should write really good commit messages. And that's something that most people do not do, but it is very important to development. If you're developing for the Linux kernel, they're very, very anal about that, making sure that your commit messages are really, they give a great explanation of what your commit actually accomplished. So here's an example of one of my commits. It doesn't really matter what it says, but you can see that it's nice and long. So this is a problem in a make file, and I sort of described what the problem was and how I fixed it. So that's pretty good. And the first line is just sort of like a broad summary of what the commit did. And some people are picky about this, and they say you should always write your commits to be in the imperative form. So fix clobbering instead of fixed clobbering, or fixes clobbering. It doesn't really matter, but that's just the accepted standard. So now we're going to take a look at a not so great commit message. I did a bit of a double take when I saw that one. Oh, okay. So yeah, so obviously the problem with commits like these is they really don't tell you anything about what actually happened in the code. And big changes, I assume that means a bunch of different features being added that maybe, are not totally related to each other. So it helps, even if your commit is something like fixes memory leak, right? Just going through the history, that doesn't tell you really. It should be something that jogs your memory, like, oh yeah, I remember that memory leak. So you should say, like, what file it was in, or what function it was in. maybe a bit about, like how much less memory is being leaked now or something like that. Okay, so branches. Branches, as I sort of mentioned before, they provide sort of isolation to the master branch. So normally when you make a commit, it's going to be onto this master branch timeline of all your commits. And branches are literally a way of branching out from that and sort of working alongside the master branch. So if you want to try out some new experimental feature or maybe reorganize your code base, but you don't want to mess up your total current development branch, then branches are a good way to do that. And you work on your own for a bit, maybe decide that, yeah, this is a cool feature, and then later you can merge that branch onto the master. And what that means is all those diffs that you accumulate when you're committing to your branch, they just get replayed over the current head of the master branch. Or alternatively, you can just maintain multiple branches. So like a lot of big projects will have sort of like a stable branch that people are supposed to download and use, and then like a development branch where people are always trying out new things. And it never gets like totally merged back in, but you might take some features and leave some other features. Okay. This is a very important tool in the Git toolbox that a lot of people don't know about, like Eric. So, changing history, yeah. So you can literally go back in time and fix your mistakes, which is not something you can do in real life, so you should be grateful. So you can go and split or merge commits. If one commit should have been 2 commits, or maybe 2 commits were really inconsequential and they're related to each other, so they should have been 1. You can improve your commit messages. Now that I gave you that stern lecture, I'm sure all of you are going to go back and fix your old commits. Right? Yeah. Nope. Not happening. Okay. And yeah, you can purge embarrassing mistakes. So like, if you make a commit and you don't really bug test it, and then you're looking at it later and you realize it doesn't compile, then you should probably go back and fix that. And you don't want to make a new commit that says, oh, it didn't work because I'm dumb. So you go back and actually amend it, and then it looks like you know what you're doing. So this is a very important tool for everyone. Git rebase and end there basically means end commits before your current commit. And that will let you go through all of those sequentially and say, oh, I want to keep this one, I want to edit this commit, I want to change this commit message, and so on. Okay, so now I can go back to what I was talking about with the distributed aspect of Git, which is really cool. It basically means that everyone is a server. In other source code management systems like SVN, you have like this master server, and everyone is pushing and pulling from that master server. But in Git, everyone is sort of their own server. So when you clone a repo, you get everything. You get all of the history. And what that means is that, well, there's 2 main benefits, which is one, if the server goes down and you're using SVN, it's like everyone has to stop. And you have to wait until that backup gets restored before you can keep developing. But if that happens in Git, you just say, okay, well, there's 20 people working on this, so really we have 20 backups, so we can use anyone's. The other nice thing is that it means all changes you make are local. So you do all your work on your local branch, and you don't need to talk to the server if you want to look at maybe old commits, things like that. And only when you want to push, you have to communicate to the server. So that means it's a lot faster. Okay, so repos on GitHub. So a GitHub repo is basically just a visual representation of your local repo, because GitHub is pretty, as I've said. And you're going to be pushing and pulling to and from your GitHub repo. A lot of people get sort of confused if they've only used Git with GitHub, and they sort of fall into this traditional like master server model, thinking that GitHub is like the master server that everyone should be pushing and pulling from. But really, it's just one more copy, like a really nice looking copy where you can have discussions and that sort of thing. GitHub also has a nice feature called GitHub Pages. So you can create a new branch with a special name, GH Pages, and then that'll be used as sort of the source for a website. You get free web hosting. So you can write like a nice website about your project, advertise it, so that's cool. Pull requests. These are a really cool feature of GitHub that you really don't get just using Git alone. So when you want to contribute to an open source project, what you're basically going to do is you want to fork their project, which means you clone their repo, you do some work on it, and then through the GitHub interface you say, hey, I made this cool feature, you should merge my branch into the master. And when you do that, you get the opportunity to write a big description of all the changes you made, and then the maintainer can choose to either accept it or make comments like, okay, but this is really poorly structured, or it doesn't follow our formatting conventions, that sort of thing. And you have a dialogue, and then hopefully it gets merged, and then you get counted as a contributor to whatever cool project it was. So again, this is an example from my own work. This is a pull request open on my RCOS project. And yeah, so you can make them really nice looking and give like a good explanation of all this stuff, because usually a pull request is pretty significant. And so you want to give a big write-up of all the stuff you did and why you think it was logical. You can reference older pull requests and issues and do these fancy code blocks, all sorts of stuff. So it's nice. That is about it for me. Like I said, I wrote a guide which actually has all the commands you should use. It's a good reference, I swear. And it's got a lot of tips. Even if you're well acquainted with Git, you should check it out. There might be something there that you didn't know about. So just go to my Gist page there, or search your RCOS mailing list archives for Git guide, or probably just Git, and it should come up. If you want a more in-depth reference for Git, there's gitref.org. And if you want help with GitHub, there's help.github.com. And that's it. Thanks to the usual suspects, Goldschmidt, Morthy, Sean Sullivan, and you guys. Questions? Yes.
So with the gist, is it possible to do like pull requests to the gist so that if somebody looks at it and sees something that you maybe didn't mention, you can possibly incorporate that?
I don't think it has support for that. You can make comments. You can
your own gist.
You could clone it, yes. I'm not sure why they don't have that. That seems pretty logical. Yeah, Gist is like an offshoot project of GitHub, and it's like a paste bin type service. But yeah, what people can see is revisions you made, which I kind of don't like, because like usually I'm correcting a bunch of dumb stuff in the write-up. Now that's all there for to see. But whatever. Just don't click on revisions. Okay. Any other questions? Yes.
I just have an addendum that I'd like to say is that if you are a student, you can get the basic GitHub Pro account for 5 free private repositories for free.
Nice. Yeah.
So if you're a student and register your .rpid address with GitHub, it will give you free private repositories.
I actually didn't know that.
But
So-
this is the open source club, so
That's
you
true.
Yes, but
probably
this is good for
not see
classwork
that.
if you want to back it up on GitHub and not lose your work if your computer dies.
Right, so a private repo basically just means that, well, no one else can see it. Only contributors to the project can work with it on GitHub, which is good for some things like secret projects or class projects. But yeah, we're trying to be open here, so usually you should just leave it open. Right, anything else? Okay.